I'm Alexander Adamov. I'm CEO and founder of the research laboratory called Nemucod Security Lab. We do malware analysis. Actually, I've been involved in this activity for more than 10 years. I started my path in security with Kaspersky Lab, then I work in Lavasoft Adware antivirus company. So finally, I have my research laboratory where I engage my students. I'm a teacher in university as well. I give lectures in malware analysis, in reverse engineering, in Kharkiv National University of Radioelectronics, and also in Sweden in Blekinge Institute of Technology. So I try to engage my students in anti-malware research and also give dedicated lectures. And also, by the way, this week I also gave a training in reverse engineering to Ukrainian cyber police with my colleagues also from Ukraine and other experts from Serbia under the head of OSCE organization. So being involved in malware analysis, we were asked many times to help with ransomware cyber attacks. So organizations come to us and ask if we can help to decrypt the data, to get this data back. And what actually, as a malware analyst, what you should do to, in order to be able to answer and help affected organization. So first is we need to analyze malware, ransomware. So we apply reverse engineering, dig into the code, and try to figure out. The second question is we try to figure out encryption model. It means we need to get key data and algorithm ID. So which particular algorithm or set of algorithms are used in this ransomware, and can we get the key? And finally, if the encryption model allows us doing that, we can create decryptor. And we face many problems on that way. The first problem is during step 1 and step 2, when we analyzing ransomware and trying to get the keys and encryption model. Sometimes we face hard-coded ciphers inside of the ransomware. Typically, the majority of ransomware, they use cryptographic APIs, so they use some third-party libraries. The most popular is, of course, Microsoft cryptographic provider, and it's easy to recognize when they call API, cryptographic API, it's easy to understand, okay, which particular algorithm, what parameters, and which key data they send to this cryptographic provider. But sometimes you just see like a lot of cryptographic transformations, and you have no clue, okay, which particular cipher it is. After a while, like, actually, you can recognize it. For example, this is MoneroPay. This is a SALSA20 symmetric cipher used in this ransomware to encrypt files. So this is breakable. Here, second and third example comes from Globe Imposter ransomware. And this is a part which represents RC4 cipher used to encrypt configuration data. As you know, ransomware comes, as many other malware, comes as a service. Like you can buy the code, the binary, and then the author of the ransomware embed your configuration data into the file, and it is encrypted in order to hide this information. And then it runs and gets money for criminal's account. And this is actually AES, part of the AES cipher, which is used to encrypt files in Globe Imposter as well. So when we figure out the encryption model, for example, like here for Cerber, Cerber is the ransomware as a service again. We can say like this one unbreakable, because here we use combination of asymmetric cryptography and symmetric. The thing is the master public key is embedded into configuration file. And in order to start the decryption process of the data, we need to have master private key. And that brings like a big advantage to criminals in order to run these extortion attacks. But sometimes they are not so complex, and I say like they're created by students who didn't study cryptography well, or they just don't care about complexity. They just want to leverage emotional part of the victim. Just say, okay, you can decrypt. You need to pay ransom, because there is no other way to decrypt your files. Among such families, there are Nemucod, Xorist as well, DeriaLock, MoneroPay, and many others that you can find, for example, on nomoransom.org portal. The first one, this is the cases from our practice. Some organization contacted us and gave us files encrypted by the ransomware. So typically, this is the original file, this is encrypted file. Typically, in order to analyze ransomware and to say if it's possible to help, we need actually the binary, the malware. But in this case, we could help because based on the extension added to the encrypted file, we figured out that this is supposedly Nemucod, and the specific of this ransomware that it uses actually one-time pod cipher with the key length 1024, byte, not bit byte, it's mistake. And they have, this is a key length, and they also encrypt 1024 bytes. So here, how these two files look like. So after 1024 byte, we have not encrypted data. So as you probably guessed already, so the thing you need to do to decrypt the data, just XOR two files, and you will get the key. The key will be 1024 byte. And there is a tool by MCSoft that you can use to break Nemucod and Xorist families. Then next one is DeriaLock. It's also not really complex. It is written in C#. It is obfuscated. So when we decompile the code, this is a .NET application, so you can easily decompile it. We found these two calls that uses the following password to generate initialization vector and key. And in the code, we also found that the algorithm that was used is Rendal, which is actually an implementation of AES cipher. So we had this password, and it is enough to decrypt the data. And here we have another problem. For example, on the picture, this is original DeriaLock ransomware, and this is a decryptor created by Checkpoint. Actually, it's a real decryptor. What they did, they just patched the program, the original ransomware, because it contained both encryption function and decryption function. So as you probably, as you understand, that it's easy just to replace encryption function with decryption. But the problem is when you patch ransomware, actually it is detected as ransomware as well. So this, on this picture, decryptor is detected by antiviruses as ransomware because the difference is just in a few bytes in the code. So this is actually not good practice, but in order to come up with a fast solution, it's okay. And in comments, you can find like, okay, this is ransomware, but it's not. It's a patched ransomware. It's decryptor. Another example is that we analyzed MoneroPay ransomware. This came as a fake SpriteCoin cryptocurrency. So the attackers, they publish a piece of news on bitcointalk.org forum, and they announce release of new cryptocurrency. And they propose just to go to their website. As you can see, the design is pretty much minimalistic. and download the crypto wallet and mining software for Windows by the link. And of course, after downloading, they got ransomware and all the files were encrypted. So after analysis, we find out that this is really simple ransomware. So it uses CISA-20 symmetric cipher. And the key was generated based on 4 strings: victim's computer name, username, user profile, and CNC address. So it was easy to, again, to patch the program, but the problem with the patch, the decryptor created as a patched ransomware, again, this is detected by antiviruses as ransomware, and it's the application is blocked and cannot be executed. And in comments they say like, okay, this is malware, Trojan ransom, but it's just patched version of the decryptor. So one of the solution we came to is to create decryptors in Python, in scripting language, which you can easily, we uploaded to GitHub, and you can easily see the code. You can easily, for example, if you have a new version of the ransomware, you can replace the password, for example, from the binary of the ransomware, and you can use it as a Python script, and you can safely execute it in corporate environment. So the conclusions. The process of decryptor creation is pretty much complex. In most cases, we cannot create decryptor because the encryption scheme uses correct implementation of asymmetric and symmetric cryptography. It requires reverse engineering skills, and it is time-consuming, especially when it comes to analysis of hard-coded or custom ciphers in ransomware. Also, when you create fast solution, like patched ransomware, it is detected by, blocked by antiviruses, and it cannot be distributed to users because users will scan it. Of course, first thing user will do is just upload it to VirusTotal. VirusTotal will tell, okay, this is ransomware. Of course, user will not run it, and it's okay. It's understandable. So the best way is whether if you're an antivirus company, if you have a lot of resources, create your own decryption toolkit, which will include all available so far decryptors. Or, for example, in our case, we decided to create like scripting decryptors so they can be easily verified, viewed, and used to decrypt the files. Unfortunately, that's we had only a few cases where we could create decryptors. So that's all. Here you can find some references to decryptors and to ransomware that I use in this presentation. If you have any questions, you are very welcome.